Hi, welcome to MACSGATE. Let us continue the subject DBMS. In DBMS, in the last session, we have seen how to use functional dependencies to identify the candidate keys for a given relation schema. Now let us continue the uses of functional dependencies. In this session, we are going to discuss two more uses. The first one is equivalence. Whenever they are given two sets of functional dependencies, we need to verify whether they are equivalent or not. That is the first one. And the second one is minimal cover. Whenever they are given a set of functional dependencies, we find another set of functional dependencies which is minimal and as well as it can cover the given set of functional dependencies. So these are the two uses we are going to discuss in this session. So let us start the session. Coming to the first one, equivalence of FDs. What does it mean, sir? They given two sets of functional dependencies. F is the first set. It is F is the set one in which we have some functional dependencies. Similarly, G is set 2 in which we are having some functional dependencies. Now we need to verify whether these two are equivalent or not. Now the question is, what is the meaning of equivalence in the case of two sets of functional dependencies? So first we need to know what is the meaning of equivalence. For that, what we do is, these are the three steps. First we verify whether the first set covers the second set, and then we verify whether the second set covers the first set. Now immediately, what is the meaning of covers? What is the meaning of covers? Or what is the procedure to verify whether F covers G or not? Suppose I want to verify whether F covers G or not. So this is what we are going to verify. In that, what we do is we assume F. We assume F. What does it mean, sir? We assume all the functional dependencies in the F are valid. Now what we do is we consider each and every FD in G. We consider each functional dependency in G. Suppose this is a functional dependency in G. Now we verify whether X implies Y is valid. Is valid. So what is the meaning of valid? Either this functional dependency should present in F. If it is present in F, that means F already covering this functional dependency. So either it needs to present in F, or the second one, it should be implied. It should be implied by FDs in F. By FDs in F. In earlier sessions, we have seen how to find additional functional dependencies whenever we have a set of functional dependencies. So for that purpose, what we do, sir, whenever I want to verify X implies Y, I find the closure of X. If this closure contains Y, that means this functional dependency is implied by the given set of functional dependencies. So this is what we are going to verify in the process of covers. So let us see some examples so that we can understand what is the procedure to verify both are equivalent or not. Okay, when F covers G and G covers F, when both are true, then only I can say both are equivalent. If any one of these fails, they are not equivalent. Let me explain with an example. Suppose these are the two sets of functional dependencies. In the first set F, I have A goes to B, B goes to C, C goes to D. We have three functional dependencies. In the second one, we have A goes to BC, C goes to D. And we need to verify whether these two are equivalent or not. The first step is we need to verify whether F covers G or not. This is what we are going to verify. For that, what should we do, sir? We need to assume FDs in F. That means we assume the FDs in the set F are valid. What are the FDs in F? A goes to B, B goes to C, C goes to D. Now what I need to verify? We need to verify the FDs in G were implied by F. So that means we need to verify each FD in G is implied by FDs in F. So let us consider the first FD. What is FD1 in G? FD1 in G is A goes to BC. The simple step is verify whether it is directly present in F. A goes to BC. I don't have any FD in F which is A goes to BC. So then the second step is identify the closure. To identify the closure, I need to use FDs in F only because they are valid. So we need to use the FDs in F to find closures. What is A closure with respect to F? Of course, I can get A. Fine. Then I have a functional dependency A goes to B. That means we can get to B. Then with B, I can get functional dependency C. So I can get C. With C, I can get D. So that means with A, I can get all the attributes, but I need only BC. Is BC present in closures or S? So that means A implies B is valid because with A, I can get the values of BC. Then what about second functional dependency in G? The second functional dependency in G is C implies D. It is directly present in F. That means no need to verify. Whenever it is present, again, why to verify whether it is implied or not? So it is present in F. So the second one also valid. What is that, sir? C goes to D is valid. So what does it mean? Two FDs in G are valid. Hence, I can say F covers G. So this is the first half of the problem. So we verify whether F covers G. Suppose in this example, we got F is not covering G. Now, no need to consider the second part because to say they are equivalent, both parts must be true. Whenever the first part was failed, why to verify the second part, sir? It is not needed. Hope you understood it. So let us continue the second part in which we verify whether G covers F or not. So what we supposed to do, sir? We need to verify whether G covers F or not. So what we need to assume? Assume the FDs in G. Assume FDs in G. What are the FDs in G? We have two FDs. What are those? A implies BC, C implies D. Now let us verify F. Let us verify FDs of F. Verify in the sense we need to verify whether they were implied by G or not. What is the first functional dependency in F? The first functional dependency in F is A implies B. Verify whether it is directly present in Z or not. A implies B is not directly present. Then what should we do, sir? We need to find the closure. So in this case, what you should use? We should use the FDs in G because we assume they are valid. So we need to use FDs in G to find the closure. So what is A closure, sir? With A, I can get A. With A, I can get BC because I have FD BC. Then with C, I can get D. Am I right, sir? So that means with the A, I can derive all the attributes, but I need to verify only whether A implies B is valid or not. Yes, of course, with the value of A, we can find B. So it is valid. What is the second functional dependency, sir? The second functional dependency is B goes to C. B goes to C. Now, is B goes to C directly present? No, sir. So let us find the closure. What is closure of B? With B, I can find B. Anything else? With B, I cannot find anything, sir. So in closure, C is not present. C is not present in B closure. What does it mean? B cannot imply C. B cannot imply C. So it means that it is not valid. Am I right, sir? So we can say G not covers F. So in first part, we got F covers G. Am I right, sir? Right. In second part, we got G not covers F. If both were pass or if both succeeds, then only we say they are equivalent. But in this case, the second part has failed. Since the second part has failed, we say they are not equivalent. Is it clear, sir? Not only second, sir. If any one of them has failed, we say they are not equivalent. Hope you understood the process. So simply we are using the concept of finding additional FDs by using the given set of FDs, right? So let us do one more example. Let us consider this. So in F, I have A implies B, AB implies C, D implies AC, D implies E. 4 functional dependencies. In second one, I have only 2. A implies BC, D implies AE. So let us continue the first part. What is first part, sir? I need to verify whether F covers G or not. Whether F covers G or not. For that, the same story, sir. Let me write in simple words. Assume F. Assume F. What does it mean? We need to assume the FDs in F. A implies B, AB implies C, D implies AC, D implies E. These are the FDs. Let us verify G. Let us verify G. What does that mean, sir? We need to verify each and FD. Each and every FD. What is the first FD in G? FD1 in G. What you are having, sir? We are having A implies BC. We are having A implies BC. Now, first verify whether it directly presents in the F or not. In this case, this is not present in F. So what should I do? Find the closure of A. For this, we need to use only the FDs of F. Anyway, with A, we can get A in any case because it is trivial. Now, with the help of A implies B, I can find B, right? Now, I have A comma B in my set. With the help of functional dependency, A implies C, I can get C. Am I right, sir? Now, anything else? No, sir. So, these are the three things we can get. That means with the help of A, I can find BC. So, what does it mean, sir? I can say A implies B, C is true. A implies BC is true because B comma C values can be derived by using A. What is the second FD in G, sir? The second FD in G is, what is that, sir? D goes to A. Is it directly present in the given one? No. So let us verify the closure of D. What is closure of D? With the help of D, I can get D. Of course, it is trivial. Anything else? With the D, I can get A, C. That is a functional dependency we have. So you can write AC. Then anything else, sir? Yes, with the D, I can get E also. Then with the A, I can get B also. So that means with the help of D, I can get all the attributes. Whenever we are able to get all the attributes, we can say D implies AD, D implies AE is valid. So we got all the FDs of G by using F. So what does it mean, sir? F covers G. F covers G. So this is the first part we have completed. Now the second part, what we supposed to do? We need to assume G. Let us assume G. So the second part we need to verify is whether G covers F or not. So assume G. So assume G means what? We need to assume the FDs in G. What are the FDs in G? A implies BC. B implies AE. Am I right? Yes. Now let us verify. Let us verify the FDs in F. In F we have 4 FDs. So we need to verify each and every FD. Let us start the first one. A implies B. Is it directly present, sir? No. So let us find the closure. What is closure of A? For this, use only these functional dependencies. So with the help of A, I can get A. With the help of A, I can get B, C. Anything else? No. Of course, we got the value of B by using A. So that means this is valid. Am I right, sir? So what is the second functional dependency we need to verify? The second functional dependency is AB implies C. It is not directly present in G. So let us find the closure. Let us find the closure of the left side. What is the left side, sir? AB. So let us find the closure of AB. With the help of AB, I can get A as well as B. Anything else we can get, sir? Yes, of course. With A, we can get BC. That is the functional dependency in G. So we can get C. Anything else possible? No, sir. So with the help of AB, I can get the value of C. With the help of AB, we can get the value of C. So this is also valid. Let us verify the third functional dependency. What is third functional dependency, sir? That is D implies AC. Of course, it is also not directly present in G. So the only chance we need to do is we need to find the closure of D plus. So with D, I can get D. And I have a functional dependency D implies AE. Using this, I can find A comma E. I have one more functional dependency with A, I can get BC. Am I right, sir? So we can get BC. That means we are able to get all the attributes with the help of D. So this is valid. Hope you people are following, sir. So what is the fourth functional dependency in F? That is D implies E. Okay. So D implies E. For this, we need to find the closure. We need to find the closure. Sir, we already got the closure. What is the closure, sir? D plus equal to D A E B C. E is present. So this is also valid. So we can get all the FDs of F by using G. That means what you can say, sir? G covers F. So in first part we got F covers G. This is true. In second part we verified G covers F. This is also true. Since both are true, what you can conclude? We can conclude both are equivalent. We can conclude both are equivalent. Am I clear in this, sir? Let us do one more example. We can try simultaneously, sir. Whenever you got a doubt, we can verify here. So let us do it very quickly. So the first part we need to verify is F covers G. Assume F. What are the FDs in F? A implies B, AB implies C, D implies AC. Let us verify G. Verify G in the sense we need to verify the FDs in G. What is the first FD in G? A implies BC. This is not directly present in F. So let us find the closure of A. With the help of A, you can find A. Then with A, I can get to B, S. With the help of B, AB, we can get C. Right? Anything possible? Fine, that's it. So anyway, we got B comma C. So this is valid. Am I right, sir? What is the second one? D implies AB. D implies AB. What is D closure? With D, I can get to D. Yes. Then with D, we can get AC. This is the FD in F. So you can get AC. Then with A, I can get to B. So we can get all the attributes. So this is also valid. So what is your conclusion, sir? The conclusion is F covers G. Now let us verify the reverse part. That is whether G covers F or not. G covers F. This is what we are verifying, sir. So let us assume G. What are the FDs in G? A implies BC, D implies AB. Let us verify F. Fine. What is the first FD? A implies B. A implies B directly not present, sir. What is A closure? With A, I can get A. I have a FD, A implies BC. So I can get B comma C. Anything else? No, sir. Anyway, I got B. So this is valid. What about the second one? The second one is AB implies C. AB implies C. What is AB closure? With AB I can get AB. With A I can get BC. Then nothing is possible. Anyway, we got C. So this is valid. What is the third one? D goes to AC. What is D closure, sir? With the D, I can get D. Then you can get B. Yeah, let me write it. D implies AB. Then with A, I can get BC. So I can get C also. Anyway, we got A comma C. So this is valid. So what is our conclusion for second half? The second half is G covers F. So we got F covers G, we got G covers F. So G comma F both are equivalent. Hope you understood how to verify the equivalence between two given sets of FDs. This is the third usage of functional dependencies. Is that clear, sir? Now let us go to the fourth use, minimal cover. What is minimal cover and how to find it? First, let me explain what is a minimal cover. Suppose I have a relation with 4 attributes, and let us assume I have a functional dependencies. A implies B, B implies C, C implies D. This is the set of functional dependencies. Now, if you observe it, I can write one more set. A implies B, B implies C. These two are enough to write, sir. No need to write the third one. Sorry, 1 minute. Just 1 minute, sir. It's not C goes to D. Actually, I supposed to write A goes to C. I'm sorry. I supposed to write it, sir. So let us assume we have 3 FDs. A implies B, B implies C, A implies C. But no need to write the third one. I can write only these two because let us assume this is G. By using this G, I can get all these values. You can get all these FDs. Am I right, sir? So that means I need to write a set with minimal FDs, but it should cover the given set. We need to write minimal FDs. So set with minimal FDs. Sir, minimal FDs means minimal number of FDs. And it should cover the given set. It should cover the given set of FDs. Hope you understood what is minimal cover. Now the question is how to find it. Sir, this is a small example so that you can easily understand. The third one can be obtained from the first two. What is the rule, sir? If you have attended the class of that one, we have a rule transitivity. By transitivity rule, by using 1 and 2, I can get A implies C. So that's why no need to mention the third one. But whenever they given a new set of functional dependencies in which we cannot guess what is the minimal cover, what is the procedure we need to follow to find the minimal cover. Let me explain the procedure first. The first one, split the FDs such that RHS contain single attribute. Suppose I have a FD A implies C. No need to do anything for this because the right side already contains single attribute. Instead of this one, suppose I have an attribute B implies D, E. So we have a FD in which B implies DE. This must be splitted. This must be splitted so that right side contains only one attribute. B implies D as well as B implies E. Now the question is, can we split like that? Yes, of course. Suppose by using Aadhaar, you are able to get name comma age. Name comma age. Let us suppose I am interested only in name. Now the question is this valid? Whether Aadhaar implies name or not? Yes, of course, this is valid. Am I right, sir? Whenever you are able to get two attributes by the given one, I can get the first attribute as well as the second attribute. But please remind this. Suppose I have xy implies z. That means with the help of xy, I can get z. In such case, I should not write x implies z because I don't know whether x on its own alone is enough to verify or to get z. Maybe I need y. I don't know, sir. So with the help of x comma y, that means whenever I know x and y, then only I can get z. Okay. When we have only x, it may be possible or may not be possible. So that's why the right side can be splitted, sir, but the left side, can be splitted, but the left side cannot be splitted. May be splitted, sir. For that, we need to have a procedure to verify it. We will see it later. So as of now, whenever the RHS contains two or more attributes, we need to split it so that the right side contains only one attribute. Hope you understood the first step. What is the second step, sir? Find the redundant FDs and delete them from the set. What does it mean? Suppose I have x implies y and some a implies b, some b implies y, something like some c implies x. Suppose I want to verify whether this is redundant or not. I want to verify whether this is redundant or not. Sir, I don't know whether it is redundant or not. So let us assume I am verifying it. Then what I do is, forget about this. Let us assume I have only these three and verify whether x implies y is valid or not. By using only these three, verify x implies y is valid or not. To verify valid or not, what should we do, sir? Just now we verified. Find the closure of x, and if it have y, it is valid. That's it. Like that for every FD. Next time I consider this one, whether it is redundant or not. Then the third one, then fourth one. Whenever I feel or whenever I got it is redundant, I will delete it because it's not needed. Whenever it is redundant, why to mention it? That is the story. The third one, find the redundant attributes on LHS and delete them. This is the story, sir. Suppose I have a functional dependency x goes to z. So the left side contains only one attribute. That means to find the value of z, I have only one way, that is only x. Then x is mandatory to find xz. Suppose I have a functional dependency xy goes to z. That means they said that you can get the value of z by using x comma y. Now the question is, are both mandatory? We don't know, sir. For example, to find age of a particular person, they said that whenever you are having Aadhaar comma name, you can find age. Now the question is, to find age, is both are mandatory? We don't know, sir. So then what I do is, first I find the closure of x. If this contains y, what does it mean? By using x, I can get the value of y. Then why to mention it separately? I will delete it. Suppose the closure of y got x, then x is not mandatory, right? So whenever the closure of one attribute contains the remaining, why to mention them on LHS? It's not needed. Suppose by using x, I cannot get y. By using y, I cannot get x. That means both are independent. Then I need both of them. Hope you understood it. So this is the story we are going to verify. So let me explain the same procedure with one example. Minimize the functional dependencies. So A implies B, AB implies C, D implies AC. D implies E. Sorry, D implies E. So what is the first step, sir? What is the first step? RHS should contain only one attribute. RHS should contain only one attribute. So the first one, it have only one attribute, so don't touch it. The second one also, we have only one attribute on RHS, so it is also according to the rule. Whatever third ones are, D implies AC, so I need to split it. D implies A, D implies C. What about the fourth one? D implies E. I have 5. Now I need to verify which of them are redundant. If one of them is redundant, I will delete it. If two of them are redundant, we will delete it. So what I do is, we do the steps. What is the steps are? We need to find redundant FDs. We need to find redundant FDs and delete them. So what we do? Let me do the first one. A implies B, AB implies C, D implies A, D implies C, D implies E. First I verify whether the first one is redundant or not. So let us assume I don't have this. Whenever I don't have this, I want to verify whether I can get it by using remaining 4. So let us assume I have only these 4. Whenever you have these 4, I need to verify A implies B valid or not. Valid or not. So find the closure. What is A closure? I need to use only this, sir. Please verify it. With A closure, I can get only A. Anything possible, sir? Nothing. So that means I cannot get A implies B. So by using these 4, it is not possible to get AB. So that means it is mandatory. It is not redundant. So A implies B is mandatory in our answer. So let us have A implies B. Then let us try AB implies C, D implies A, D implies C, D implies E. Now let us try whether you can get the second one or not. So forget about it. Let us consider only the remaining 4. What are the remaining 4? These are the remaining 4s. What I should do, sir? I need to find the closure of AB. With AB, I can get AB. Anything else possible? With A, I can get B. I already have B. So A implies C, I cannot get. That means it is not redundant or it is not extra, because I am unable to get it from the remaining. So the second one is also not redundant. Let us verify the third, fourth, fifth. What is the next one we need to verify, sir? First let me write it. D implies A, D implies C, D implies E. Now we need to verify the third one. So for that, what we need to use? We need to use only the first 2, the last 2. So let me write it here, sir. What is D closure? With the help of D, I can get D. With the help of D, I can get C. With the help of D, I can get E. Anything possible, sir? No. But I am unable to get A. So that means it is mandatory or it is compulsory, right? So sir, instead of writing redundant, not redundant, I am using one more word. That's it. So the first 3 are mandatory. Let us verify the fourth one. Again, let me write it, sir. A implies B, AB implies C, D implies A, D implies C, D implies E. So what we supposed to verify? We supposed to verify the fourth one. Let me use only the remaining remaining four. Find the closure. What is D closure? With D I can get D. D implies A. D implies yield. Then A implies B I can use. Then AB implies C I can use. So that means what, sir? I am able to get D goes to C. It is valid. Sir, it is valid means it is extra. It is not mandatory. So D implies C is not compulsory or is not mandatory. Not mandatory or redundant. You can use the technical word redundant. So delete it. Let us consider the fourth one. A implies B, AB implies C, D implies A. We removed the fourth one, sir. It's not needed. Now I want to verify whether the fourth one is extra or not. Right? Now let us continue the closure. What is the closure of D plus, when closure of D? With D I can get D, A, B, C. Are you able to get E, sir? No. So that means D implies E is mandatory or it is not redundant. So these four are mandatory, sir. What is the result of the second step? In the result of second step, we confirmed that A implies B, AB implies C, B implies A, D implies E. These four are mandatory. This is the output of the second step. Now let us continue the third step. So what is the output of the second step, sir? What you got, sir? A implies B. Then AB implies C. A implies B. AB implies C. D implies A. D implies E. Now we need to apply step 3. What is step 3, sir? In LHS, find redundant attributes. Find redundant attributes and remove them. Anyway, coming to the first one, A implies B. In LHS, I have only one. Sir, whenever we have only one employee to do our work, he is mandatory. Suppose I have 2 employees, then I will get a doubt that whether both are mandatory or not. So for the second one, AB implies C. So let us try it. Find the closure of A. With A, I can get A as well as B because I am able to use A implies B. Right? So that means A closure contains B. So B is not mandatory. That means B is redundant. So I can remove B from here. So A implies C. Sir, suppose I got A is also redundant. That means B closure contains A. Then you can remove any one of them. Right? That means whenever we are having 2 employees, both can do the work. Then we can remove any one of them. Right? Then what about the third one, sir? D implies A. The LHS contains only one. So don't do anything it. D implies E. The same. So finally what you got in the third step? A implies B, A implies C, D implies A, D implies C. So this is the minimal set with which you can cover the given set of functional dependencies. With which you can cover the given set of functional dependencies. Hope you understood the process. What is the first step, sir? RHS should contain only one attribute. What is the second step, sir? Find the redundant FDs. Maybe this is the lengthy step. We need to consider each and every FD and we need to verify whether it is redundant or not. That means whether it can be obtained from the remaining one or not. The third one, find the attributes in which LHS contains 2 or more. Whenever I have 2 or more on LHS, find the extra attributes or redundant attributes. Remove them. That's it. So let us do one more example. Fine. So this is the question, sir. Please go through it. Consider the set of functional dependencies. P goes to QR, Q goes to R, P goes to Q, P goes to R. And I need to verify whether, I need to verify the correct canonical cover. Sir, canonical minimal irreducible. All they mean same. So let us start the problem. What is the first step, sir? Consider, okay, first of all, let us consider it. So the given P goes to QR, Q goes to R, P goes to Q, then PQ goes to R. So what is the first step we need to do, sir? The RHS must contain only one attribute. RHS must contain only one attribute. So then the first one should be split, sir. P goes to QR. This should be split into P goes to Q, P goes to R. Fine. The second one, Q goes to R, sir. That you can write as it is because RHS contains only one attribute. Am I right, sir? Then what about the third one? P goes to Q. Right. Then the last one is PQ goes to R. Sir, here the RHS contains only one attribute. Fine. So these are the 5 FDs we are having. I think let us continue in the next slide. So what is the answer of the first step, sir? They are right. And if you observe it, P goes to Q, P goes to Q, repeated. Whenever it is repeated, no need to consider for 2 times. You can consider for only 1 time. So the output of the first step is P goes to Q, P goes to R, Q goes to R, PQ goes to R. Totally 4 FDs. So let us continue with 4. P goes to Q. Then what is the second one, sir? P goes to R. Then we have Q goes to R. The last one is PQ goes to R. So let us try which of them are redundant. First, let us continue the first one. Then what I need to verify, sir, whether I am able to get the first one, the remaining 3. Find the closer. With P, I can get P. With P, I can get R. PR. That's it. Anything else? No, sir. So that means I am able to get only 2. So this is mandatory. That is mandatory. So it is not redundant, sir. Again, let us write the 4. P goes to Q, P goes to R, Q goes to R, and PQ goes to R. Right? So let us verify the second one. Use the remaining 3. What are the remaining 3, sir? That's it. So find the P closer. With the P, I can get to P. I have P goes to Q, sir. So I can get Q. I have Q goes to R, sir. So I can get R. So I can get this one. So what does it mean, sir? I am able to get R. I am able to get R. So what does it mean? It is extra or it is not mandatory or it is redundant. Whenever it is redundant, we can delete it. When you delete it, what else you have? P goes to Q, Q goes to R, P2 goes to R. Fine. Now let us verify this one, whether it is implied from the remaining. Let us assume only these two. What is PQ closer? With the help of P, I can get PQ, then I have a dependency Q goes to R. So that means I can get R. So this one. That means with PQ, I can get R. So it is redundant. Whenever it is redundant, delete it. Then what else you have, sir? You have only 2 more functional dependencies. P goes to Q, Q goes to R. These are the outputs of the second step. What the third steps are? LHS. We should not write contain, sir. Find redundant on LHS. Find redundant. Attributes. On LHS. P goes to Q, Q goes to R. Sir, please observe, for the first one on LHS I have only 1. Sir, whenever you have only 1 attribute, it is mandatory. Without it, we cannot do anything. Similarly, the second one also having only 1. So it is mandatory. Both are mandatory. So what is our conclusion or what is the output of the third step? The minimal cover for the given one is P goes to Q, Q goes to R. Right, sir? P goes to Q or Q goes to R. So what is the step, sir? P goes to Q or Q goes to R. Clear, sir? So this is about finding minimal cover for the given set of FDs. Hope you understood it. Thanks, sir. So in the next session, we see what is decomposition of a relation and what are the properties of decomposition. That means what are the properties we need to keep in our mind when we decompose the given relation. Okay, or why to decompose. So all these details we discuss in the next session. Hope you enjoyed the session. Thank you.